Good morning, class. Circles, arcs, and tangents appear throughout engineering, cam profiles, gear teeth, pipe bends, road curves, and architectural arches are all defined by circular geometry. In technical drawing, you must be able to draw circles tangent to lines and other circles, draw arcs blending between straight lines, and construct common internal and external tangents. Nigerian road engineers designing roundabouts, like the ones on the Lagos-Ibadan Expressway, use tangent arcs to ensure smooth transition from straight road to circular curve. WAEC technical drawing consistently tests circle and tangent constructions. Essential circle terminology. Center, the fixed point equidistant from all points on the circle. Radius, distance from center to any point on the circle. R. Diameter, distance across the circle through the center equals to R. Circumference, the perimeter, a distance around the circle equals 2 pi r. Chord, a straight line joining 2 points on the circle. Diameter, the longest chord, passes through the center. Arc, a portion of the circumference. Minor arc, semicircle, major arc, semicircle. Semicircle, exactly half the circumference. Sector, a pie slice, region bounded by 2 radii and an arc. Segment, region between a chord and the arc it cuts off. Tangent, a line that touches the circle at exactly one point, the point of tangency. The radius to the tangent point is perpendicular to the tangent. Secant, a line that cuts through the circle at 2 points. Concentric circles, circles with the same center but different radii. Key theorem, the angle in a semicircle is 90 degrees. Any triangle inscribed in a semicircle with the diameter as one side is right-angled. Tangent from an external point to a circle. Given, circle with center O, radius R, external point P. Required, draw tangent from P to the circle. Step 1, draw line PO. Step 2, find midpoint M of PO, perpendicular bisector of PO. Step 3, draw a circle with center M and radius equals MO equals MP. Step 4, this new circle intersects the original circle at points T and T2. Step 5, draw lines PT and PT2. Result, PT and PT2 are the two tangents from external points P to the circle. Verification, angles OTP and OT2P are both 90 degrees, angle in semicircle of the construction circle. Common external tangent to two circles, same side. Given two circles with centers O and O2, radii R and R2 respectively. Step 1, find the difference, or sum for internal tangent, of the radii. Step 2, construct a circle with center O and radius, R minus R2. Draw tangent from O2 to this smaller circle. Step 3, the tangent direction from O2 gives the tangent lines to both original circles. This construction is more advanced, typically WAEC test individual external tangents from a point. Tangent to a circle at a given point on the circle. Given, circle with center O, point T on the circle. Required, tangent at T. Step 1, draw radius OT and extend it slightly beyond T. Step 2, erect a perpendicular to OT at point T. Result, this perpendicular is the tangent at T. Since the tangent is perpendicular to the radius at the point of tangency. Arc blending, fillet arc, round corner. A fillet arc smoothly connects two lines or curves. Connecting two straight lines with an arc of radius R. Step 1, draw lines parallel to each original line at distance R, one on each side toward the angle. Step 2, the intersection of these parallel lines gives the center C of the blending arc. Step 3, from C, drop perpendiculars to the original lines, these are the tangent points T and T2. Step 4, with center C and radius R, draw the arc from T to T2. Result, a smooth arc connects the two lines. Application, Nigeria's road transition curves, pipe elbows, sheet metal corners, casting foleys. Circle through 3 points. Given 3 non-collinear points A, B, C. Step 1, construct the perpendicular bisector of AB. Step 2, construct the perpendicular bisector of BC. Step 3, these bisectors intersect at center O or the circumcenter. Step 4, with center O, radius OAE equals OB equals OC, draw the circumscribed circle. Finding the center of a given circle. This is the same procedure, any two chords perpendicular bisectors intersect at the center. WAEC technical drawing questions on circles and tangents. Question 1. What is the relationship between a tangent to a circle and the radius at the point of tangency? Answer. The tangent to a circle is perpendicular to the radius drawn to the point of tangency. This means the angle between the tangent line and the radius equals exactly 90 degrees. This is a fundamental property used in all tangent constructions. Question 2. Describe how to draw a tangent from an external point P to a circle with center O. Answer. 1. Draw line segment PO. 2. Find midpoint M of PO by constructing the perpendicular bisector. 3. Draw a circle centered at M with radius MP equals MO. 4. This circle intersects the original circle at tangent points T and T2. 5. Draw lines PT and PT2. These are the two tangents from P to the circle. Question 3. Define the following circle terms: chord, segment, sector. Answer. Chord, a straight line segment joining 2 points on the circumference of a circle. Segment, the region of a circle bounded by a chord and the arc it cuts off. There are two segments, minor and major. Sector, the region bounded by two radii and the arc between them, shaped like a pie slice. Question 4. Describe the construction of a fillet arc of radius R connecting two perpendicular lines. Answer. 1. Draw lines parallel to each original line at distance R, on the inside of the right angle. 2. These parallel lines intersect at point C, the center of the fillet arc. 3. From C, draw perpendiculars to the original lines to find tangent points T and T2. 4. With center C and radius R, draw the arc from T to T2. The arc smoothly blends the two perpendicular lines. Question 5. 3 holes are drilled at corners of a right-angle triangle with leg 60 mm and 80 mm. A technician wants to find the circle that passes through all 3 hole centers. Describe how to find its center and state its radius. Answer. 1. Construct perpendicular bisectors of 2 sides of the triangle. 2. Their intersection is the circumcenter O. 3. For a right-angle triangle, the circumcenter is the midpoint of the hypotenuse. Hypotenuse equals square root 60 superscript 2 plus 80 superscript 2 equals square root 3600 plus 6400 equals square root 10,000 equals 100 millimeters. Circumradius equals hypotenuse slash 2 equals 50 millimeters. Circles, arcs, and tangents are not merely academic, they are the geometry of motion and smoothness. Every rotating machine part, every road curve, every pipe bend in Nigerian infrastructure is defined by circular geometry. Mastering these constructions gives you the skills to design and document products and systems that function smoothly and safely. Powered by Lightech Academy academy.lightech.com.ng NERDC-approved SS1 Technical Drawing.